Well, here we've got another buffer problem. This is the question number 4. It talks about phenol. Phenol is a very interesting compound. Its older name is carboxylic acid. It's an interesting compound. You've got a very, very stable benzene ring, and then you've got an alcohol. But because this benzene is pretty stable, this H plus can leave as an acid without having a double bond oxygen. It's because of the OH here, it's got hydrogen bonding and will dissolve in water somewhere. It's melt solid at room temperature, but will melt at about 50 degrees. It's a pretty nasty compound, though. It's useful for chemical reactions, and originally was used as an antiseptic, but it is pretty nasty. And if you work with it, wear gloves and maybe a face shield, because you don't want to touch your face if you've touched anything that has phenol on it. But okay, let me get away from there onto our question. It's question 4. So each part's worth about 1 point. Here we've got B. One of the first things you should look at when you see an acid is you look at the Ka. And this weak acid has a really, really low Ka. I mean, times 10 to the negative 10. If you were to take a 1 molar solution of this, the hydrogen ion concentration would be in the area of 10 to the negative 5, a pH of 5. So even a 1 molar solution would be very, very mildly acidic at a pH of 5 here. So I know it's an extremely weak acid. It's a weak acid that partially dissociates into water, and they've got the equation. Now, this is one of the things that you should know. We've got our acid, and then we've got our conjugate base, which is paired with it. And it's going to be a pretty decent base, because the weaker the acid, the stronger its conjugate base. But on to the question. For a certain reaction involving phenol to proceed, the phenol must be primarily in its deprotonated form, I mean without the H+. So it's going to have to be primarily in the form of its conjugate base. In order to ensure that the phenol is deprotonated, the reaction must be conducted in a buffered solution. On the scale below, circle each pH for which more than 50% of phenol molecules are deprotonated. Now, that's a pretty complicated question. First thing I'm going to do this. And if you've got a Ka and you have a buffered problem, you're going to have to find the pKa. I mean, especially when they talk about pH. And that's easy enough to do. Just take the negative log of the Ka, which here is, you can just barely see, is the log of 1.12 times 10 to the negative 10. It's got a pKa of 9.95. So that's a pretty high pKa. I mean, the higher the pKa, the weaker the acid. Now, it's a buffered solution, and a buffer solution has both base and acid in it. And the two contribute to the pH. Here's the Henderson Hasselbalch, which is really great for pHs and buffers. All you've got to do is find out the pKa. You just get from the Ka, okay, 9.98. And then you have the log of the amount of B over the amount of A. Well, in this case, if you have a 50-50% solution, B, let's say, is 50 and A is 50, we've got the log of 1, which is 0. The pH is equal to the pKa. You should remember that if you have a 50-50 mixture of the buffer, where you've got the same amount of acid and conjugate base, the pKa equals the pH. It's the perfect buffer. Now they're saying that they want even more base than acid. Well, if you do that, your log value is going to be greater than 0. And we're going to have a pH with a pKa plus some number. So our pH is going to be 10 at least. And if you add enough base and it's concentrated enough, you might even be able to get up to 14. I think if you put this at 13 too, they'd give you full credit, because getting to a pH of 14, good luck. You're going to have just completely conjugate base of phenol. But they said the correct answer was 10 to 14, but they would also accept 10 to 3. Well, okay, that's our answer. When you're dealing with buffers, figure out how much acid you have, how much conjugate base of that same substance, and then pull up the Henderson Hasselbalch. Oh, and also don't forget to get the pKa, because that's what you're going to start off with. So, okay, that's it.